All right, so source transformation, just another tool that we can use to help us solve circuits. Basically, if we have a voltage source, and we're going to do this in AC, of course, in series with some impedance, let's call this just Z, we'll just call this V, we can equivalently redraw this or transform this source into a current source, I, with the same impedance, Z, in parallel, and it will behave exactly the same in a circuit. Basically, we would get the same exact behavior looking this way in both circuits. This would be I and this would be Z, and the only thing that we need to do in order to obtain one or the other is use Ohm's law. So if I have this voltage source and this impedance Z, all I need to do is take this impedance Z and move it over here. And then in order to get this I just use I is equal to V over Z, where this Z is here and this V is here. So I'm just using Ohm's law on this voltage and this impedance to determine the current that I would need in my transformed current source, okay? And so that's going this way. If I want to go the other way, and I want to convert this into the voltage source in series with the impedance, all I got to do is take my impedance again and just move it over here. And then for my voltage, I just use Ohm's law. V is equal to I times Z, where this I is here and this Z is here. And then that voltage is the voltage that I would use in my transformed source. Okay, so that's about all we got for source transformation. It's pretty straightforward. It's really just going to be used for if you ever want to solve a circuit. So let's say that you had a circuit that looked like, oh, I've got a current source, I, with some impedance here and some other impedance here, and then an impedance here, and this just doesn't look like a fun problem to you. Well, what you can do is you can take this source and transform it into a voltage source. So basically from this point over, you can transform it into a voltage source in series with that same impedance, and then what you're left with is just the rest of the circuit, right? You would just take this and tap it on over to the end of this circuit, and now I'm left with just a real easy KVL single loop circuit that I could solve really quickly just by transforming my source into a voltage source in series with an impedance rather than dealing with the current source in parallel with an impedance, okay? And so you can go both ways with that, but that would be one possible use case. Just wanted to get that out there and just show another topic that we should review that worked in EE220 and is going to work well in EE221 as well if we ever need to utilize this to solve circuits. Okay, so we're kind of through the vast majority of this module, and in the last little section here, I'm going to talk about op-amp circuits because it's pretty important to be able to solve op-amp circuits in AC, because a lot of op-amp circuits, actually most op-amp circuits, are going to be dealing with AC inputs. Okay, so everything we saw in EE220 with op-amps is still valid, but we're going to be looking at a couple of kind of newer, obviously it's going to be a little bit different because we're going to have AC sources and we're going to have AC outputs and all that. So let's go ahead and stop this video here, and then in the next final section of module 1, we're going to go over op-amp circuits.